All right, so we're going to try to find the derivative or take the derivative of this equation with respect to x. Okay, looking at this function, it should be pretty clear how complex it is. We're taking a cotangent of an exponential whose exponent is a sine function of a linear function. So there's a lot of layers to this. We're definitely going to need to apply the chain rule. So first things first, the derivative of y with respect to x, of course, is just dy dx. Right? The next thing is to start to take the derivative of this thing layer by layer from the outside in. So we're going to write the derivative of the cotangent. Of course, we know derivative of cotangent is negative cosecant squared. Since it's cotangent of all that other stuff, we're going to write all that other stuff inside here. So it's cosecant squared of 3 to the sine of negative 2x plus 1. Now, we have to multiply by the derivative of that other stuff, right? So if you have the derivative of an exponential function, 3 to the sine negative 2x plus 1, we're taking that derivative, so we're going to multiply this by 3 to whatever it's being raised to, right? So since that's a function, we're going to write sine of negative 2x plus 1, and we're multiplying all that by ln 3. So we've now taken care of this exponential layer. Of course, we then need to multiply by the derivative of whatever the exponent was in that function. So we need to multiply by the derivative of sine. Derivative of sine, of course, is cosine. So it's going to be cosine of negative 2x plus 1. But since it's not just sine x, we have to multiply by the derivative of the input of the sine. And so we're multiplying all of this by negative 2. Of course, this is not simplified, it's just written out, but hopefully you can follow the process of peeling back layer by layer.